In this lesson, we're going to learn about counting with multiplication. So normally we count with addition. So if you're counting something up, you would count one after another and add them all up. But we can also count with multiplication. So that's what we're going to do at the beginning here, and then we're going to lead into something called a permutation, which I'll get to later in the lesson. So let's start with just counting. A sporting goods store offers three types of snowboards: all mountain, freestyle, and carving, and also two types of boots, soft and hybrid. How many choices does the store offer for snowboarding equipment? Use a tree diagram, then the counting principle. So uh, let's just start with the tree diagram. So what this means is we have three types of boards. We have all mountain, freestyle, and carving. I'm just going to abbreviate them like so. Then for each of those options that we have for types of board, we have two options for the type of boot. So if we choose the all mountain snowboard, we could have either soft or hybrid boots. So either soft or hybrid for that. If we choose freestyle, we could again have either soft or hybrid. And if we have the carving, we could have either soft or hybrid. So for each of the three types of board we could choose, there's two types of boots that we could choose. So the total number of ways that we can make choices here is going to be 6. Now we could switch this around. We could say, well, we've got two options for the boots, soft or hybrid, and for each one of those that we pick, there's three options for board. So if we choose soft boots, we could have either all mountain, freestyle, or carving. And if we choose hybrid, we could have either all mountain, freestyle, or carving. And again, we have 6 options, whichever way you do it. So the counting principle, what that tells us is that if we have one event that can occur in some number of ways and another event that can occur in some number of ways, if we want to find all the possibilities for that, we just multiply them together. So there's 3 types of snowboard, 2 types of boot. If we multiply those together, we'll get the total number of ways that we can have all of those combinations. If we have 3 events, we just multiply all 3 of them together. More than 3 events, again, just multiply all of those together to get the total possible ways. Okay, let's look at example 2. Colorado license plates typically have 3 numbers followed by 3 letters. How many possible license plates are there if there are letters and digits can be repeated? Okay, so we've got 6 spots. 1, 2, 3, 4, 5, 6. So it's usually 3 numbers, which means that for the first one, so there's 10 digits that we use, 1 through 9, and then 0. So we've got a number for this one, number for this one, number for this one. And then for the letters, well, there's 26 letters in the alphabet. So I'll say L for letter. So we've got 3 numbers, 3 letters. Okay, so for the first number, we could have 10 different options. Again, there's 10 digits, 1 through 9, and 0 makes 10 digits. And then there's 10 options for the second one, 10 options for the third one. And then for the letters, there's 26 options for that letter, 26 options for that letter, 26 options for that letter. And so to get the total here, what we can do is we can multiply all of these together. And if we do that, 10 times 10 times 10 times 26 times 26 times 26, what we get is 175760000. So that's about 17 million. 17 million different possible license plates. Well, now let's do something a little bit different. So let's say if we have the same concept, except we're not going to allow ourselves to repeat digits, which is not how license plates work, but just as an exercise, let's do it. Okay, so again, we've got numbers for the first 3, and letters for the second 3. Now for the first one, we've got any of the 10 digits is fine. But once we've used one of them, then there's only 9 left for the second one. So if the first one, say, is a 2, then the second one could be anything but 2. So there's only 9 options left. Well, once we've used 2 of the digits, then there's only 8 left for the next one. And then for the first letter, well, we could use any of the 26 letters in the alphabet. But once we've used one of them, then there's only 25 left for the next one. And then once we've used 2 of them, there's only 24 left for the next one. So then using the counting principle to count up all the different ways that we could combine these together, we're going to multiply all of them together. So it's going to be 10 times 9 times 8 times 26 times 25 times 24. And we get 1123200. So that's about 11 million. So not as many, but still quite a lot of combinations of letters and numbers that we can have there. All right, example 3. Let's look at all the ways that there are to order the letters A, B, and C. Okay, so we could just write these out if you wanted to. So, we have A, and then B, and then C, and then we could say switch B and C around. Or we could have, B, and then A and C, and we could keep going and list all of those, but let's do this a little more systematically. So we've got 3 spots. Well, for the first letter, we could have any of the letters A, B, or C, so we've got 3 options for that spot. And for the second letter, well, we've already used one of them, so we're going to have 2 options for the last spot, or the second spot. And then once we've used 2 of them, that only leaves 1 left, so we've only got 1 option for that spot. Using the counting principle, we can multiply these together. 3 times 2 times 1 is 6. So what we just did there is something called a factorial. This is a new operation that you're going to learn in this lesson. It is denoted with an exclamation point, so this n exclamation point, that's read n factorial. And what that means is to take whatever number, n, and multiply it by all the numbers less than it. So if we want to do, say, 6 factorial, we do 6 times 5 times 4 times 3 times 2 times 1, that's 720. So what this tells us, if we do factorial, it tells us the number of ways that we can arrange that many objects. So if we had, say, 6 letters, so A, B, C, D, E, and F, we could arrange them in 6 factorial different ways. So again, if we do that, we've got 6 spots. That's 5, 6, there we go. So for the first letter, we'd have 6 different options. We could choose any of A, B, C, D, E, or F. For the second one, we've got 5 options. The next one, we've only got 4. The next one, we've got 3 options. The next one, we've got 2 options. And then we don't have a choice for the last one. Multiply all those together. That'll tell you the total number of ways you can arrange those letters. So if anytime we want to know how many ways there are to arrange some number of objects, we just take that number and multiply by all the numbers less than it, which again is this factorial operation denoted by an exclamation point. All right, example 4. 10 teams are competing in the final round of the Olympic 4-person bobsledding competition. Part A, in how many different ways can the teams finish? Okay, so if we're looking at all 10 teams, we've got 10 spots here. So we have first place, second place, third place, fourth place, and then I'm not going to write the rest, but 5th place, 6th, 7th, 8th, 9th, and 10th place. So before anyone has crossed the finish line, there's 10 teams, so we could have any of the 10 teams cross the finish line and get first place. So we've got 10 options for first place. Once one of the teams has passed the finish line, there's only 9 options for second place. And once 2 of the teams have gotten first and second, there's only 8 options for third place, 7 options for fourth place, 6, 5, 4, 3, 2, 1. Multiply all of these together to get the total number of options. And this is, again, 10 factorial. So if we want to know how many ways there are to arrange these teams, how many ways there are for these 10 teams to win, we just do 10 factorial. That means take 10 and multiply it by all the numbers less than it. So if we do that, 10 factorial, that is 3628800. So it's about 3.5 million. All right, part B. In how many different ways can 3 of the teams finish first, second, and third? So typically when we're doing races, we don't care about 4th, 5th, 6th, 7th, 8th, 9th, 10th place. Typically we just care about first, second, and third place. And that's it. That's all we care about. So that's what we're going to do now. So for first place, again, we've got 10 options. Any of the 10 teams could finish first. For second place, we've got 9 options. And then for third place, we've got 8 options. And that's all I care about. So if I'm just looking at first, second, third place, I don't care about what order all of the rest of them finish in. all I care about is first, second, and third place. So we're just going to look at the options that we have for first, second, and third place and multiply those together. So we're taking 3 of the teams out of the pool of 9 and seeing how many ways there are for 3 teams to win out of a pool of 10 teams. So again, what we do is 10 times 9 times 8, and that gives 720 different ways. So what we did here is something called a permutation. So we chose 3 objects from a group of 10, objects being places that the teams can finish. And this is where order matters. So we care about which one's in first, which one's in second, and which one's in third. This is called a permutation. And so what we did here is we calculated only 3 of the 10. And so how this is written is we have 10 objects and we're choosing 3 of them where the order matters. And so like we did just above, we did 10 times 9 times 8. Well, another way that we could look at this is as 10 factorial divided by 7 factorial. So 10 factorial is 10 times 9 times 8 times 7 times 6 all the way down to 1. 7 factorial is 7 times 6 times 4 times 3 all the way down to 1. And if we look at this, we can start canceling. So these cancel, 3's cancel, 4's cancel, 5's cancel, 6's cancel, 7's cancel, and then we're left with 10 times 9 times 8. And so actually how we can write this would be like this. We could write this as 10 factorial divided by, and then if we take 10 minus 3, that's going to give us 7, 10 minus 3 right here. So the reason why I'm doing this is because this is actually a formula that we can use in order to find a permutation. So personally, I don't really like this formula. I think it's cumbersome and messy, but we're going to look at it anyways because this is the formula for permutations. For me, I think it's much easier just to do this 10 times 9 times 8 business than it is to plug in all these numbers into the formula. But it's good to know that the formula exists and how to use it. So let's go to example 5. This is choosing 5 objects from a group of 8 where the order that we choose them matters. So this is a permutation. And so what we can do is we can take this 8 and 5 and just plug it in here. So we could do 8 factorial divided by, and then n minus r, that's 8 minus 5 is 3 factorial. And if we do 8 factorial, that is going to be 4320. And then 3 factorial is 6. Divide that out, and we get 6,720. And again, we could have just done this the way that we did it before. So we've got 5 places, 5 things that we're choosing, 1, 2, 3, 4, 5. And then for the first option, we've got 8 options for the first spot, 7 options for the next spot, 6 options for the next spot, 5 for the next, and 4 for the next. And if you multiply all of those together, you will get, comma should be there, 6720. So you can do it either way. Again, I prefer to do it this way, but the formula is there. You're welcome to use that if you prefer that.